So all the addition algorithms that we've looked at in this section will work in other bases. And I'm going to push you to practice these in other bases because I know you're already comfortable with base 10. And I really want you to understand the value of these algorithms. And I think you'll be able to appreciate that more in a base system where you're not quite as comfortable. All right, so before we can add though, it's really important that we can count. So let's make sure that we can count. We're gonna look in base 5 for this video. So if I'm in base 5, I have 0, 1, 2, 3, 4. And now when I get up and add one more, that's gonna get me to 1, 0, base 5. And then I'm gonna add 1, 1, and then 1, 2, 1, 3, 1, 4. And now when I add 1 to 4 every time, that's going to bump it up a level. So I'm at 2, 0, 2, 1, 2, 2, 2, 3, 2, 4, and then 3, 0. I'm going to fit a little bit more. 3, 1, 3, 2, 3, 3, 3, 4. Hopefully at this point you see the pattern. I get 4, 0. And actually, let's go a little bit more. 4, 1, 4, 2, 4, 3, 4, 4. What's going to come next? So when I add 1 to 4, 4, well, I'm going to add 1 to the 4s in the units, and I can glue all of those together to build a long, right? So now I have 1 extra long. So now I have 4 longs and 1 long, but that's 5 longs. And anytime I get 5 of something, I can glue it together to go up a level. So that's going to get me to 1 flat and 0 longs and 0 ones. Okay. And then 1, 0, 1, etc. Okay, so make sure you can count in base 5. Once we can count, we can add without too much trouble when we're adding single digits using the same techniques that we talked about at the beginning of this section. So perhaps you want to use the number line, for example. So I've got the numbers written out, and so if I wanted to add, say, 4 plus 2, I could, or counting on even, let's do that. I could do 4, and I want to count on 1, 2. That gives me 1, 1, right? So 4 plus 2, if I'm reading the table, here's 4, and here's 2. I'm going to read column and row, and so 4 plus 2 is 1, 1. All right, so let's look at some more complicated examples. Here we've got 3, 4, 3 base 5 plus 2 base 5. Okay, so you could use the table to help you figure this out. If I add 3 plus 2 in base 5, that's going to give me 1, 0. Let's use the standard algorithm. I'm going to put my 0 ones down below, and I'm going to carry my 1. Now I have 1 plus 4. That also is 1, 0. So I'm going to put my 0 down below and carry my 1. And then 3 plus 1 is 4. So that's where that's coming from. Here's my concrete model, so you might want to pull out some base 5 blocks or draw pictures just like this. If I want to add 1, 2 plus 3, 1 base 5, that's 1 long and 2 ones plus 3 longs and 1, 1. In this case, I don't need to regroup anything, right? So I'm left with 4, 3 base 5. We can use the expanded algorithm in base 5. So 1, 2 is really 1, 0 base 5 plus 2 base 5. And 3, 1 is really 3, 0 base 5 plus 1 base 5. And now I'm just going to add my 1s. So I get 1 plus 2 is 3, and then add my 10s. I have 10 plus 30. I'm sorry, I shouldn't call them that. 1, 0 plus 3, 0 to get 4, 0 base 5. And now I can add those to get 4, 3. All right, we saw on the last slide how we could use the standard algorithm with regrouping. All the other algorithms that we looked at also will apply in base 5. So you can use the lattice algorithm, you can use the scratch algorithm, you can use the compensation. we want to get comfortable with all of those. You can think about making 1 0. So instead of making 10 now, we're making 5, right? That's what 1 0 represents, to help you do that addition.